Concentration of a solution. We know that the concentration of a solution is defined as the amount of solute present in a known amount of solvent or solution. Concentration can be expressed qualitatively as well as quantitatively. Qualitatively, we describe a solution as either dilute or concentrated. When a solution contains a small proportion of solute relative to the solvent, we call it a dilute solution. On the other hand, a concentrated solution contains a large proportion of solute relative to the solvent. This qualitative means of describing concentration, although useful, sometimes leads to confusion, and thus arose the need for a quantitative description of solutions. Quantitatively, the concentration of a solution can be described in several ways. These methods are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity, and molality. Let us now study about each in detail. Let us first discuss the mass percentage or weight by weight percent method. The mass percentage of a component of a solution is defined as the mass of the component in the solution divided by the total mass of the solution multiplied by 100. It is important to note that as we are expressing the concentration in percentage, it implies that we are defining it per 100 units of the solution. If X grams of component A is dissolved in Y grams of component B, then the mass percentage of A is given by X, which is the mass of A, divided by X plus Y, which is the total mass of the solution, multiplied by 100. For example, a 10% weight by weight solution of sodium chloride in water means that 10 grams of sodium chloride is present in 100 grams of the solution. Note here that 90 grams of water and 10 grams of sodium chloride make 100 grams of the solution. Another way of expressing concentration in percent is volume percentage or volume by volume percent. The volume percentage of a component in a solution is defined as the volume of the component divided by the total volume of the solution multiplied by 100. The concentration of solutions where both the solute and the solvent are liquids is commonly expressed using this method. For example, 15% of ethanol solution in water means 15 milliliter of ethanol is dissolved in 85 milliliter of water such that the total volume of the solution is 100 milliliter. Yet another way of expressing concentration in percent is mass by volume percentage. This is expressed as the mass of the solute divided by the total volume of the solution multiplied by 100. For example, a solution of 23% weight by volume contains 23 grams of solute per 100 milliliters of the solution. This way of expressing concentration is widely used in medicine and pharmacy. It is important to note that when a solute present in a solution is in a very small quantity or trace amounts, then its concentration is expressed in another quantity known as parts per million or ppm. Parts per million or ppm is defined as the ratio of parts of the solute to million parts of the solution. Mathematically, it is expressed as the total parts of the component divided by the total number of parts of all the components of the solution multiplied by 10 to the power of 6. The concentration can be expressed as mass to mass, volume to volume, or mass to volume. For example, the concentration of dissolved oxygen in seawater is 5.8 grams per 10 to the power of 6 grams of seawater and is written as 5.8 ppm. Also, the concentration of pollutants in water or the atmosphere is often expressed in terms of ppm. Now, let us discuss another commonly used concentration term, the mole fraction. The mole fraction of a component in a solution is defined as the ratio of the number of moles in that component to the total number of moles of all components in the solution. It is represented by X. Mole fraction is an ideal way of representing the concentration of various chemical species in a mixture. It is useful for representing concentrations in gaseous mixtures. Another very important method of expressing the concentration of a solution is molality. It is represented by small m. Molality is defined as the number of moles of a solute dissolved per kilogram of solvent. Mathematically, it is represented as m is equal to n, the number of moles of the solute divided by the mass of the solvent in kg. If Wb grams of the solute is dissolved in Wa grams of the solvent, then the expression for molality becomes m is equal to Wb divided by the molar mass of the solute multiplied by 1000 by Wa.